Hello everyone, it's been a while since I recorded my last video lesson, so who knows how this will go. In any case, we are starting topic 10. It's a little out of our previous order, but circumstances are a little unexpected. Anyways, we're dealing with function operations. It is a real function notation heavy topic, but in terms of its content, not the worst thing in the world. We're going to see things graphically, we're going to see things algebraically, adding, subtracting, multiplying, dividing functions, and then, as the last topic, we'll be composing functions, having functions of functions. But for now, sums and differences of functions. If we have two functions, say f and g, for example, we can add them together, or we can subtract one from the other. From a graphical perspective, we're essentially looking at the y values that happen for every x value. If you want to add two functions together and create a resultant function from that, we're looking at those y values. Like over here, this has a y value of 3 when x is whatever this is, 1, 2, 3, 4, 5, negative 6. And over here when x is negative 6, y has a value of negative 2. So when we look at h of x being f of x plus g of x, we're really saying in this case, well, you could say h of negative 6 is f of negative 6 plus g of negative 6. But that's the same thing as 3 plus negative 2. h of negative 6 is equal to 1. When we do this graphically, we can do this point by point. So we look at the next value over. Over here on f, y is equal to 3 again. But now on g, y is negative 1. And 3 plus negative 1 is 2. Therefore, h of that x value, h of negative 5, is 2. And we proceed down the way. F is still 3, g is 0. Therefore, we get that value. F is 3, g is 1, so h is 4. F is 3, g is 2, h is equal to 3 plus 2 equals 5. So that's how we tackle this. You can take a moment, try completing the rest if you want. Feel free to pause this video at any time. It's the usual kind of mode of operations. But I will now finish this one off. How far does this go? All the way to there. Now, the originals weren't just discrete values. This was continuous over its span. So don't forget to connect the dots. You should use a ruler if you're dealing with straight lines. Call that a win. Ta-da. Honestly, don't really like that particular line thickness. Oops. Don't mind me just trying to function. Really, snaps into place, eh? winner. All right. Questions, comments, concerns? Haha, that joke's old. I'm going to move on to the next example. Now, worth noting about this example, we had the same domain for each f and g. So this first function went from -6 to +6 for its x values. G went from -6 to +6 for its x values as well. And so our resultant function also went from -6 to +6. Green on pink is questionable at best. It could be the case that the domains don't match. Over here, we see that one function is restricted. This one's restricted between -3 and 4. But this other one goes on forever in this direction. The sum or difference function, whichever we're tasked with sketching or analyzing or algebraically getting an equation for, its domain will only be what's common to the original two functions. This one has a lower limit of -infinity. This one's lowest possible value is -3. So the lowest possible value we can actually take the sum of is when x is -3. That's where this whole thing starts. We still add these as we did previously, point by point, looking what happens when x is -3, taking those values and doing something with them. -2 plus 2 is, oh, that's 0. Cute. Next one over. That and that. That, oh, my pen's on super thick. That's what's going on. Next one's over. We got 2 and 2. Next one's over. We have 2 and 3. And we go next one over. When x is 1, we've got 4 and 1, so 5. When x is 2, we have 5 and 0, so there's 5 again. When x is 3, oh, x can't be 3. That's outside of the domain of f, so it's outside of the domain of h. These are all the points we'll see on h itself. Well, the discrete value, the lattice points anyways. We do need to play connect the dots. Note, this is not going to be a curve, so we're not taking this and saying, it gently swoops through. No. A line plus a line is always a line. So when you actually connect the dots here, just make sure that there's some rigidity, so like there's clearly a distinct angle change here. So it's not a gentle curve. It's just bing, bang, boom. Do you feel? Yeah, definitely feel. Now, those two are all about adding functions together. Next one is subtracting. But same. We're just making sure that we subtract instead of add. Now we do have a cutoff point for this domain as well. Why not purple? All right, this is our lowest value over here. That's where this whole thing gets cut off at -4. So if we look at this graph, none of this matters. They do both extend onward forever to the right, so hooray, huzzah for that. But on the left side, lowest value is -4 for x. And we go from there. Take a moment again, try it yourselves, see how things go. No, wait, I show you the first point. Where's my pink at? Remember, we're subtracting now. Here's -2, or here's +2, and here's -4. So when you look at h of -4, what's the value of this difference function when x is -4? That's f of -4 minus g of -4. F of -4 we've said is +2. G of -4 is -4. We should get a value of 6. So when x is -4, h of x is 6. The honestly easiest way to get tripped up here is just in the basic arithmetic. If you're processing things mentally, which is probably the most efficient way to process things in this case, just be a little extra careful. Don't rush things. I don't know how many times I've made the mistakes, made that kind of mistake. It's a silly mistake to make, and it kind of sucks. So just be careful that you're taking those basic operations slowly-ish. Anyways, continue through, see what you get. Feel free to pause the video again, but I'm going to forge ahead in a moment or 3. I don't know what that is. I do know what that is. This many. 2 minus -2. Where am I at? 2 minus -2 again. Material. Still that. Alright, what's happening here? That's 1 minus -1. That's like 2. And then 0 minus 0, 0, and I guess that's just going to continue. Same pattern. Neat, super, swell, splendid. This is me playing connect the dots. On the left side, solid dot, because that's a distinct and, but because f and g both continue on forever ever, so will h on the right hand side. Cool beans? Yeah, Mr. A, the coolest beans. Thanks, everyone. Last little bit of this is just shorthand notation. So we've seen these things where we've said f of x plus g of x, or f of x minus g of x. Oh my goodness, it takes so much time to write. How come we're writing x so many times? Ugh, the efficiency or lack thereof, it's killing us. So, shorthand notation. If you want to say f of x plus g of x, you can just simply say f plus g of x. Wow! You saved like a whole character. All those time savings. What are you gonna do? And same for f of x minus g of x, the difference. We'll say that's f minus g of x. Ta-da! Ooh, check this one out. We've got both f and g on the same set of axes. And then we'll draw their sum here. We'll draw their difference there. When I was preparing for this, not gonna lie, I made a mistake on the difference function because I kept forgetting which one was f and which one was g. I was like, yes, top one is f, bottom one's g. It was not the case. So just be careful of that. Obviously, it doesn't quite matter with the sum because the order doesn't matter when you add things together. But subtraction gotta makes a difference. Ooh, no pun intended. Give these a try. I'm going to forge ahead soon. I'll do it now. Pew. Pew, 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 pew. A line plus a line is a line? What madness. Arrowheads at each end because each goes on forever and ever. And bloop. This other one. That's good. So that's those two done. There is some practice work. It's in the textbook. Well, that doesn't seem like so much. Oh, that's not so bad at all. I'm so generous. Wait till you see tomorrow's. It's less generous. But, have fun with it. Please actually try it. Let me know if you have questions as you work through it. Believe in yourselves, believe in the dream. And, happy April. I will see you one day in the future. The end.